Hello everyone, so let's start. What if I told you that instead of training a neural network from scratch, it takes days and thousands of data points, you could just borrow a brain that is being already trained over that stuff. Okay, so that's exactly what transfer learning is. It is one of the most powerful trick in deep learning. Let's break it down. So imagine you are learning to drive a car. You don't start from zero. You already know the traffic rules, particle awareness, and how road works. You just need to learn the car specific stuff. Transfer learning works in the same way. You take a model that is already being trained on a massive data set like the ImageNet for the images, Wikipedia for the text, and instead of starting fresh, you reuses what is actually being learned and just adapt to the new task. The key insight is that deep learning networks learns in layer. Early layers learn simple stuff, edges and shapes and basic patterns. Later layer learns the complexity and task specific stuff. You have a general knowledge before starting the loop. Now what bothers here is that the problem with the starting training with these scratches that you need tons of data, weeks of compute time and everything. With transfer learning, you can just get great results with a few hours, hundred of example. Training goes days to hours, and model has already been having a rich and meaningful features. Okay, now that's a very small topic, so we'll be learning that how much data you have. So for that we have feature extraction. You freeze your everything in the pre-trained model and just slap a new output layer on the top. Super fast, works great with your dataset when it's tiny. Second, we have the partial fine tuning. What happens here is that you unfreeze the last free layer and retrain those with a new head. Then you have the full fine training. Unfreeze everything and retain the whole network, but it is very small. It will be having a very small learning rate, so you don't destroy what already is being done. Okay, now there's a zero shot and a few shot. This is what models like GPT and clip are powerful. I've also written a paper over it, few shot using the clip part. I'll attach the link in the description also for that. There are a few things that can save your pain while fine tuning, that using a tiny learning rate like 1 into 10 raised to the power minus 4 or even 1 into 10 raised to the power minus 5. If you go too high, you will just override all the pre-trained knowledge, and that's called as catastrophic forgetting, and it's very bad as it sounds. Second, we have the layer wise learning rate. So lower your learning rate from the early layers, slightly higher for the later layers in the heads, and always use a warm-up schedule. Let's the learning rate ramp up slowly at the start before it settle down. Some of the real world use cases are that using of the ResNet and the EfficientNet on the ImageNet that get fine-tuned for the medical images, detecting tumor, reading x-rays and all these things. BERT and GPT get fine-tuned for segmentation analysis, chat box, summarizing, basics of the all the modern NLPs. Now Whisper get fine-tuned for low resources languages where almost no speech data exists, and Clip connect images and text so well that you can just classify them into categories the model has never seen before. So to wrap up, transfer learning lets you stand on the shoulder of a giant model instead of starting from zero. Matches your strategy of your data size, keep your learning rate small, and never skip evaluation on a clean set. This is what transfer learning is. And to be more honest with you, I'll tell you that this topic is important to be covered because many a times when we are working with models, when we are working with architecture, we use some of the pre-trained data only, pre-trained models only, and we just fine tune on our data. For example, if I want to train a model over cars, so in spite of getting thousands of images of car, I take a data that is being already trained on cars. I'll fine tune it on the types of cars that I want. For example, if I want that model to detect Wagoner, so what I'll do is that I'll give it some hundreds of images of Wagoner so it can detect which part is Wagoner. So this is called as fine tuning. It's also a part that is being done in this transfer learning only. So to wrap up, in the end we can say that transfer learning is something that makes our task really easy, and we don't need a high GPU, high computation for this. That's all. Thank you.